we're switching gears today. We're going to be talking about communications and collaborations. And so we're starting off with communications to a scientific audience. And so Rob Lennox is a fantastic writer. I get him to proofread almost everything that I do, whether it's blogging or paper or whatever. I find him to be an extremely effective communicator of science, and so I, of course, wanted him to help everybody and to talk to you about his different views on writing papers. He has so many different ways that he goes about collaborating with people and organizing papers, and he has a lot of experience as a reviewer as well, so he's bringing in that experience as well. And today he's going to be giving just some tips on how to present your scientific information, mostly within papers, but just in general to a scientific audience. So thank you, Rob.
Thank you very much, Kim. So when I was in high school, I really didn't know what I wanted to do or what I liked to do, and I really wanted to be a marine biologist, and I didn't know if I would get there. And my second choice was journalism school, because the only thing that I thought that I could ever really do effectively and enjoy was writing. And when I was making those decisions as a 17-year-old, which is a strange time of your life to be making really consequential decisions about where your entire life will lead you, I kind of thought that if I could write all the time, I would be really happy. But I thought, playing in the ocean would be a lot more fun, and I left that behind. And somewhere along the line, those paths kind of merged, and I realized that I was naive, and I didn't realize that a huge part of being a scientist was actually writing. And when I realized that it was, it really sort of solidified for me that it was potentially a good path. So I've always enjoyed writing. I've practiced it a lot. I've developed that skill as much as I could. I've worked with some incredible writers and gotten advice and tips from some of the best in our field, I think. And it's something that I'm passionate about and really interested in and trying to actively develop. And I think there's a lot of lessons that everybody can learn about writing. And here are some. I put together some slides about some of my experiences writing, as well as being a reviewer on papers, and trying to notice the challenges associated with scientific writing and some of the opportunities to effectively communicate. And let's put together a quick slide about what we're trying to do. So we're trying to publish research that's relevant and interesting, and we want to address a certain audience. So we want to address stakeholders, in particular, people that will use the knowledge that we're producing. So writing effective papers and communicating these lessons that we're learning from research is extremely important. And I think all the time about the millions or billions of dollars of research that's on floppy disks or in file drawers that isn't mobilized and isn't available to stakeholders or potential knowledge users. And it's a huge inefficiency. So part of the reason that I'm very passionate about publishing papers is simply the realization that it's the only way to ensure that the investments that we make, our time and money and effort and energy and all the late nights spent working and worrying about how projects will go, it's really the best way to ensure that that research becomes usable, not only within a couple of years, but potentially, many years down the road, potentially past our lifetimes. And so I think scientists have an obligation to publish research in order to develop this knowledge. And I strongly believe that everything is publishable. Essentially, essentially everything that we do adds knowledge, and somebody can find use in it. And that it's really important to take it seriously and realize that even when you get negative results, whether you get inconclusive results, there's often lessons, and depending on how you communicate that and the lessons that you're able to find in that, you can address a specific audience that can benefit from that. So we're never trying to write the perfect paper, in my opinion or in my experience. It's about trying to write an effective paper. So we want to just communicate the results clearly. We want to make data available, so not just the findings, but ensure that the raw data are archived and available to future users for things like meta-analyses and synthesis projects. I want to connect it with other relevant research, both within the field and beyond the field, and create opportunities for future research that can build off of it. So some myths, I think, about scientific writing that I've seen during my time doing it, that publishing research is difficult. I don't think that's necessarily true. It's just that it takes practice. Everybody that I've ever worked with has gotten better at writing over time. It's not because it's an extremely challenging endeavor. It's merely that there are certain rules and guidelines, and when you follow them, you can write an effective paper. Peer-reviewed research is the gold standard. In fact, I think it's just the starting point for generating knowledge. Having a peer-reviewed publication is not the end of the road. Communicating that research and sharing papers with intended audiences and building off that knowledge with future research, connecting it via meta-analyses and review and synthesis and perspective papers is really important. Replications and null results are not interesting. That's totally untrue, of course. Replications and null results are critical to advancing science. Doing these experiments is a really important role for scientists to have in making sure that it's publishable. I talk to people all the time that get rejection letters, unfortunately, from journals that justify rejections because they're replications or their null results, and I think that's, in my opinion, in my experience, that's not an effective way to be conducting science, to be closing the doors to people that are doing these really important projects. And expert researchers plus peer review produces flawless research. There are a lot of mistakes in published papers. You need to read these papers with a critical eye. You need to think about the conclusions that people draw. There's an idiom, I forget where it's from, that you should not attribute to malice what can adequately be explained by incompetence or lack of knowledge. People make mistakes not necessarily because they want to, or they're lazy, or they have malicious intent, but because mistakes happen, and it's not always a bad thing. Pointing those out and being critical with other people's research is a good thing. I took my first year at university here at Dalhousie. I took a class from Tim Jukes on scientific writing, and I learned a lot about writing in that class, and a lot of those lessons really only crystallized years down the road. So these are some things that, when I read papers, kind of drive me a little bit crazy. Misusing spatial and temporal terms. The wrasse swam as it was startled. We read things like that all the time. It's better to say the wrasse swam because it was startled. Using while is a temporal term. So while the findings are conclusive, more research is needed. There's really no need for a temporal term there. Although the findings are conclusive, more research is needed. I find to be a more effective way to communicate that statement. Confusing which and that. I see this a lot in research and journalism and writing. The fish which was tagged. I find that a very difficult to interpret sentence or statement. The fish that was tagged is more effective to me. And always using serial or Oxford commas when listing. So the tag had temperature, depth, and acceleration sensors with no comma is, I find, very difficult to understand what's going on there. The tag had temperature, depth, and acceleration sensors, I think, is more effective. So some tools for effective writing. I use Google Docs almost exclusively now for writing scientific papers. I didn't always, but it's really streamlined to a huge extent the way that I write papers, especially collaborating with other people. Sending around one version and having people comment on it is very difficult. You have version control issues. You have some people that are really busy and they delay the process by a month or more because they don't get back to you. Google Docs, you can send out a link to everybody. Everybody has access. You can tag people in comments so that they get an email so they know exactly where in the document they need to address. It backs up online automatically. There's version control so you can go back and look at previous versions. It's just a really effective way to write papers, and it can shave off almost half the time that it takes dealing with collaborators and comments because everybody can work on it simultaneously when they have time. If they have the link, they can sign in or they can log in or they can open it up whenever they want, and it usually gets done a lot more effectively that way. You can also access them offline, so it's not only online. You can get the version online, and when you sign back into internet, the changes that you've made will update automatically. Some that I don't use as much. Zotero is apparently an excellent open source reference manager. A lot of people use EndNote. I've never really used reference managers, although people seem to love it. Zotero is apparently a really good alternative. GitHub, I'm going to start to learn to archive version and version control my code. Jake mentioned that briefly yesterday. I think it's a fantastic tool, and I need to develop those skills. R Markdown can assist with R workflow. I don't use it personally, but there are apparently a lot of benefits. Same with the R Shiny app and some other tools within R, and Zenodo for free data archiving. So obviously we all use Ocean Tracking Network database for telemetry data, but other data that are not necessarily specifically related to telemetry can be archived for free in Zenodo. So writing strategies, when I work with people, the number one thing that I always recommend is start a working document as soon as possible. It's a living document, and you can always build on it. So the first thing that I do is usually try to write out methods, because it's the first thing that's conducted in a study. When I'm out in the field, I start writing the method section so that it's already done. I find it's way easier to build on a document than to start it from scratch. So conducting a whole study and then opening up a blank Word document is very stressful. It's hard to remember exactly what I did. It's hard to remember exactly the story I'm trying to tell. But when I have a living working document where there's already text in there, I can scroll down to wherever I find text that sort of hooks me in, and I read a sentence, and all of a sudden I'm ready to go from there. I read something, I can build off that. I can work with that. I read something about that last week. I was talking to somebody at the workshop about this paper. I'm going to go find it. I can cite that here, things like that. When I'm reading, no matter what I'm reading, and I come across something that is potentially relevant to a paper that I'm writing, I immediately open the working document and I write a sentence out that approximates what I'd try to say about it, and I add in that citation and the reference. So I never have to go back, or rarely have to go back and find what I was reading 2, 3 weeks or months ago. It's already in there, and I can modify the wording, but I have an idea of what that citation is saying. As I'm doing that, and I'm reading through my working document, I start to reorganize sentences, things that go together, get matched together. Paragraphs form. Paragraphs get moved from introduction to discussion. Methods are already there. As I'm doing data analysis, I'm adding in results, and the paper basically writes itself in that way. Writing out discussion bullet points whenever they come to mind. Often when I'm writing the introduction, I'm thinking about things that could be potential discussion topics, and I just write that in the discussion as a bullet point. Potentially as a header or a topic sentence for a paragraph about limitations to the study or future research directions. I find the introduction and the discussion are often very complementary, so information that sometimes I write initially in the introduction, I think, no, I'm going to save that for the discussion. It's really more of a future direction. Adding and modifying is just always easier than starting from scratch. Titles I find very interesting. I'm really interested in hanging titles because you see them more and more. There's some really funny ones, fantastic yeasts and where to find them, about the hidden diversity of dimorphic fungal pathogens, and then ones like boomeranging around Australia, historical biogeography. To me, I find the fantastic yeasts and where to find them very on the nose. I think it's funny, it's clever. Boomeranging around Australia, I don't really understand. I don't see how anything to do with equatorial fish has anything to do with boomerangs, but so whenever I'm looking through titles, I often see some that I find very funny or not very funny, and I send them around because I think there's a very clear distinction to me between which ones I like and which ones I don't. Titles should always be informative. If you've read some of the articles that I've written, you see that a lot of the titles are basically just statements of fact or finding. They're not very creative or clever, because I just try to think about what search terms people might use if they were trying to find the information in the paper. I use Google Scholar personally a lot, and that's how I build my titles, basically, is if someone was interested in this research, what might they search? What would I search? Research should be fun in many ways, I think. So hanging titles can be fun and lighthearted. They can also be confusing. There are, I think, 5 papers that build off the Hobbit there and back again about salmon migration. So at least be unique. If you have a clever title, then it's awesome, but try to make it stand out. Nobody is likely to be searching in Google Scholar there and back again to try to find a paper about salmon migration. Most people will only read your abstract, so I think you should spend a disproportionate amount of time ensuring that the abstract provides clear information. Even people that are going to cite your paper, they may only read the abstract, so always be strategic in the information that you provide in the abstract, such that you want to make sure that the key results are described in enough detail that somebody can cite it if that's all they've read. So there's people going to be moving through, scanning through your abstract, just looking for a citation for a statement that they've already made, and you want to be able to hook them in. Common mistakes I find when I've read abstracts as a reviewer: excessive background. Really, the results are what's important. Nobody's going to read your abstract or cite your abstract based on what's already been done. Too much methodological detail. Again, focus should really be on the results. If people are you want to hook people into the methods and get them into the paper to read the whole paper. So if they're really interested in the methods, you can pull them down to the main text. And results are often understated, making it difficult to cite. So I've emphasized that a couple times. But if you don't really emphasize what the results or the findings are, then a lot of people will pass on your paper quite quickly, unfortunately. And lacking key conclusions and implications. Most introductions, I think, are generally too long. A lot of journals now have really strict length requirements. Probably that it's not just now, but I'm just starting to notice it. I try not to waste words on the introduction as much as possible. We had a great talk from Andrew Hendry, who's at McGill, while I was doing my PhD at Carleton, and he suggested 3 paragraphs for your introduction, a very simple system. The baby, the werewolf, and the silver bullet. You describe a system or something that people care about, something that's threatening that system, and then in the 3rd paragraph, you set up an experiment that's going to figure out how to resolve or better understand that threat to that system. Almost all the papers that I write, I aim to write one single spaced page of introduction. Sometimes it bleeds down to about 1.5 pages, but for me that's as much as I think most people are really interested in reading, and it's usually enough to effectively communicate the introduction material. Tailoring the introduction to fit the journal. If the first paragraph is about fish, it's usually going to be best suited for a fish journal. Thinking about exactly how you want to frame your study, I think, really makes a difference on how you begin your introduction. The first paragraph, in my experience, is really critical to where that paper ends up going. If you want to publish a paper in a journal like Ecology or Journal of Applied Ecology, Ecological Applications, American Naturalist, your first paragraph really needs to focus on something about ecological theory and something like density dependence, something that or biogeography or landscape energetics, some theory that you're explicitly testing. That's how you can hook reviewers or editors in and convince them that you're using a model system, maybe a fish telemetry system, to study this ecological question, but the paper is really about this. So that first paragraph is really how you frame, that really determines the fate of the paper in my experience. Final paragraph in an introduction is most challenging. Avoid stating a statistical hypothesis. When I'm a reviewer, I often see people talking about null hypotheses and alternative hypotheses. Not really an effective way to outline an experiment. I usually lean towards making predictions instead of hypotheses because they're much easier to understand and they're much more clear. And you need to transition to the method section smoothly, but not really describe methods in detail. So you can talk about how telemetry is a perfect system to test this hypothesis, and then get into the methods as a nice transition. But it's not necessary to go into great detail about the number of receivers and the number of fish that are needed or used in order to conduct a study. Just quickly interject upon my own talk that, of course, these are general guidelines, and I believe very strongly that all advice is based on survivor bias. What works for me does not necessarily work for everybody else, and I wouldn't advocate to do things exactly as I say, but pick out things that you think are interesting and that work for you. You have a question, Jay?
Sorry, I didn't mean to interrupt you. I was just going to add in terms of getting into higher impact journals, I think you have to put a substantial amount of effort into your letter to the editor. And that's something that I never understood early on. It took me a really long time to figure out that, like, the way that you frame the paper in that letter should be a lot of time and effort that goes into that if you really want to get into ecological applications or something like that.
Yeah, so Jake recently gave me some great advice on cover letters. I always put effort into them, but probably not nearly enough effort. What Jake suggested to me was to really focus on other literature that had addressed a similar topic that was in the journal that you're submitting to, and discussing exactly how your paper sort of interfaces with those those papers that that journal has already published, but builds upon the knowledge. And I think that's really good advice, because it really can hook in an editor to say, well, I handled that paper. It was a good paper. Like, let's see what this paper now has to offer. I think that's definitely good advice. Thank you, Jake. Method sections are of extreme importance. For some reason, they're last in some journals in Nature and PNAS. That always throws me off. It's ideal to divide these into different sections. So study site, study species, experimental design, data analysis. Breaking things up into subsections makes it much more readable, I think, especially because these sections can be quite technical and potentially quite long. And many readers will be particularly interested in specific subsections. Some will really want to know what you did for data analysis. Seeing it smoothly or clearly described under a subheading can be very helpful for some readers. Data analysis section should provide the perfect template for reporting results. Just do it in the exact same order. It really doesn't have to be complicated. When I write a data analysis section in a methods, in parallel I start writing out the results, and I can fill in what the p-values and the test statistics are later. But oftentimes when I review papers or read other papers, the data analysis is scattered within a method section. And when you're reading the results and you're trying to go back and you see a p-value or a test statistic, and you're like, okay, which test exactly was this? Was this the linear model? Was this the mixed effects model? Was this the GAM? It's not really clearly laid out. They're all jumping around in the methods and jumping around in the results, and you can't match them up. It's just easier to make sure that they align pretty perfectly, and you can go down the list in both and say, okay, this was the first test method. This was the first test result. This was the second test method. This was the second test result. It makes everything shorter, because when you do it that way, it becomes much more concise, and it makes everything much more readable. Data analysis section should really focus on facilitating replication. That means citing R packages. And in my opinion and experience, I always try to cite the R functions. When I was first starting out with writing papers, I would read something and think, wow, I could do that with my data. It's a great analysis. And then I could never find exactly what they did. I had to do a ton of Googling to figure out a complementary method and not even know if it was the same thing. So I always put the function in there, so if somebody is reading my paper and they like what I did, they can go to that specific package and look at the exact function that I used. And I think that it's important for facilitating other people to be able to understand what you did, both for replication of your own results as well as replication of your methods for their own study. And I think hopefully, I don't know, no one's ever come up to me and said this really helped me out, but hopefully at some point somebody looks at it and says, okay, now I can do this with much greater efficiency. Results should be the easiest section, simply because it should just follow the methods, the data analysis section. You've already laid out exactly what you're going to do. There's no discussion, there's no interpretation, you're just saying exactly what you got. Avoiding imprecise statements about p-values. About 20% of the papers that I review simply say p was greater than 0.05. Just not an effective way to communicate. It's way easier to just give the equivalency, p equals 0.16, whatever it is. As well as the test statistic. Long sentences is a clue that information could be stored in a table. Oftentimes when I see sentences that are going 3-4 lines in a results section, a lot of that information should just be transferred to a table. I use tables with great reliance, and it's important not to restate information in tables and figures that in the text. Just refer to them, and refer to them in parentheses, not directly. So activity increased with temperature, figure 1. Not in figure 1, we see how activity increased with temperature. Discussion, I always use the first paragraph to emphasize the key take-home messages. If people read your paper, they're going to read, like 90% of them are just going to read the abstract. The other 9% are probably just going to read maybe the first and last paragraph of the introduction, probably the first paragraph of the discussion, and definitely the last paragraph of the discussion. So if I need to know a key result, I go straight to the last paragraph of the discussion, sometimes the first paragraph of the discussion. So ensuring that the key information is there, I think, is quite important. You can divide this into subheadings. Certainly for writing it can help. You can get rid of them later if you want to, but ensuring that it's sort of following a logical order and that the information is contained within sections clearly is crucial. And the final paragraph really needs to sum up all the paper. You can put it under a conclusion subheading or not, but really many people only read the last paragraph of the paper, or at least look there for the study's ultimate finding. And that's not just my own experience. I've been told that by others as well. I'm going to start flying through this now because I realize that my time is getting short. So making figures is the most fun part. Maps are fun and easy to make with ggplot, as I showed 2 days ago. I really like making colorful plots, but they're expensive to publish in journals. There's more and more online journals that don't care, but I've started just submitting color figures and saying, publish this online color only, and in the print version you can publish it in black and white, and there's in brackets in the figure title it just says refer to online version for color. So I had a quick exercise which was too ambitious to look at some Crocs data from the VTrack package and look at all the different ways that we can visualize the data. So one question of what's the depth distribution, how does the depth distribution of these crocodiles differ? There's a lot of different ways you can plot it. So you can plot it with points, where I've used geom_jitter. So instead of having them overlap, you see the distribution, and you can say that the day and night is colored differently. You can have a continuous path track of the depth. You can look at the mean and the standard error going up and down. You can make violin plots like this, where you have densities. So you can see the day and night densities of the two individuals. You can have ridge plots, which are conceptually similar to the violin plots, but flipped up and overlapping a little bit. You can have box plots. That's all essentially the exact same data, the exact same question. There's a lot of different ways to plot it, and you need to think critically about the best way to present that information. And oftentimes it's quite important to communicate the data as honestly as possible, which means showing the variability. So in my opinion and experience, I find box plots tend to hide the data a little bit. I like violin plots a lot. I sometimes use ridge plots, but it always depends on the question. So if you get really lucky, sometimes you can get a really good shapefile. When you're working in a new spot, I think it's the first question I always ask is, can I get a shapefile for this? Otherwise, I got to use something like ggmap or marmap. Selecting a journal. Andrew Hendry has a great long series on this in his blog. He always suggests aiming high because there's a low cost of failure and a high benefit of success. He also suggests society journals because the fees go back into society. So journals like conservation biology, the fee that you pay goes into the Society for Conservation Biology. Open access journals are often expensive. Some differences in editorial experience. So some journals, in my experience, like Frontiers in Ecology and Evolution, I'm pretty sure their editorial manual says you basically can't reject a paper if you're an editor because their business model is publishing papers for money. They're often corporate, like Frontiers and PLOS, but there are some great free options for open access journals. So I love Boreal Environment Research. It's free. It's open access. You can publish in it for free, and everybody can read it. It's run by the University of Helsinki, I think. The competing factors are time it takes to get it finished and published, so you don't want to be just resubmitting a paper 15 times until it gets accepted. And 2, impact factor, personal goals, visibility. And of course, beware of predatory journals. It's a waste of resources. It's bad for science. You can often spot them, but they're getting harder and harder to find. So this is an example, the International Academy of Ecology and Environmental Sciences. If you're unsure about a journal, then talk to your advisor, email people in the field, contact the editor of the journal, get more information. And my conclusions, enjoyment of science is often reflected in the quality of the paper. So hanging titles can be fun. People seem to love them. Hidden allusions in the paper. I have lots of people tell me that they hide references to Bob Dylan and Hitchhiker's Guide to the Galaxy. Colorful figures, that's what I really enjoy. I like making nice plots and maps. Simplifying the message, that's crucial. Ensuring that anybody that's wanting to get information from your paper can access it very quickly and easily. It helps it be read and cited and shared. Get feedback early and often. It's never too early to send a draft around. I'm sure everybody's heard that, but it's really true. The easiest way to improve is to get feedback and to practice. describe data analysis in detail. I really can't overemphasize that. It's really difficult to read a paper where you don't actually know how the data were analyzed. Use subheadings. Breaking up the paper is effective. A lot of journals have clickable subheadings, so you can actually navigate through the paper fairly efficiently just by getting the subheading that you're interested in and going through like that. And sink your teeth in. That just means writing as much as you can, starting early, having a living document, often in Google Docs I would recommend, that you can add to, that you can add references to, that you can start making sentences in, that you can write a method section early on. The quicker that you embrace the process of writing a paper, the more efficiently you will be able to do it, and the less difficult it will be. Writing a paper is really not hard. It takes time and practice, and I strongly believe that everybody is capable of being an excellent scientific communicator. And I hope that some of these things have been interesting or new to you. I don't think I have time for questions, but let's talk about it in the afternoon potentially.